This is the foundational technology of human civilization. Up until recently, the earliest evidence for human-made fire was found in France and dated to around 50,000 years ago. But now, there's new evidence, found in a disused clay pit in the east of England. This evidence is much older, 350,000 years older. But what I want to know is, how can we possibly know this? How do we gain such knowledge from so far back in our prehistoric history? How do we know this wasn't just evidence of a lightning strike or a forest fire? And what does it mean for the very earliest chapters of the story of humanity? To answer this question, we're going to travel across the country, meet the team that made this breakthrough, and find out how they put the pieces of this puzzle together. And it all starts here.
First I only came for an extended weekend. I've been coming here for every summer for the last 10 years. We are in a disused clay pit. This clay that you see behind me used to be dug in the 19th century to make bricks. They started finding some stone tools like hand axes and also some animal bones that indicated humans were there a very long time ago, and many archaeologists got interested over the years. This would have been a watering hole. We know that because the clay, white and grey clay that infill this pond, they preserved very well the bones, the shells, the pollens, so we know which species were around. We can see that there are pike, tench, that kind of fish. We also know that large mammals came to drink at this pond. Some animals that are no longer living in this part of the world, elephants, some macaques, some lions with very, very large paws. Some dating was done, and that tells us we are in the first half of the interglacial, just after the Anglian glaciation, that's 425,000 to 400,000 years ago. I'm taking you to the area where the evidence of fire have been found. Well, this is the fireplace where we found the heated sediment. Unfortunately, we cannot remove the tarp to show you, but we always do like photogrammetry to have a 3D model of the area. We can see the darker sediment at the top, that's the soil, and just below you have this reddened clay that were heated by the fire. And you really can see this deep shaped as you normally have in a fireplace. It's very interesting because it was in situ. It had remained as it was 400,000 years ago. For us, it was very good news because we knew that will facilitate all the scientific analysis, and that would allow to demonstrate whether or not it was a human-made fire.
We've now seen our first major piece of evidence, this 400,000-year-old reddened clay that appears to be a fireplace. And we've also seen what this surrounding area was like, a watering hole where elephants and lions and other mammals came to drink. But there's other key pieces of physical evidence that were found at this excavation site. But to see those, we need to go to the British Museum.
This little piece of rock has rewritten our earliest human history by an amazing 350,000 years. Having found the reddened clay, I just had this hunch that this was something big. And it was really over the next 2 or 3 years that it began to all come together. So all these objects in front of you were excavated from the site. First of all, we had the reddened clay. Secondly, we have these heat-shattered hand axes, and third, we have these tiny little pieces of iron pyrite. So the first piece of evidence is the actual sediment, the reddening you can see in the middle here, and you can see that darker horizon at the bottom and also above, and that's the ancient soil, and within that we have this reddened clay. And this sediment here was one of the samples that we sent off for preparation in Germany and analysis in Austria, and there were two things it told us. First of all, the sediment was in situ, it hadn't moved, and secondly, and this is all important, the sediment had been heated. Here we have an example of an unaltered hand axe. You can see it's splint, and we call it hand axe, sometimes called a biface, because it's been flaked on two sides to create this teardrop shape, and this is undoubtedly human made. In the area of the reddened sediment, we also had 4 hand axes that have been altered by heat, and here we have one of the 4 examples, and here you can see the pinkish tinge of the flint, which is quite different to the darker colour of the unheated hand axe. And even more significant, you can see where tiny chips have come off. These were found next to it, and we've refitted them back onto the piece, and that sort of greyish mottled tinge of the altered flint underneath. These are all characteristic of flint being heated. And this is really curious because we've only got 8 hand axes in total from the site, and we found half of those hand axes next to this area of reddened clay. What's going on? Are they throwing the hand axes into the fire? We really don't know, but it's really strange. The third piece of evidence we have are these 2 tiny fragments of what we call iron pyrite, and this is well known for when it's struck against flint to create sparks, and the sparks can generate a fire. And we found this in association with both the heat-shattered hand axes and the reddened clay. Initially, when we found it, we thought, well, you know, maybe it's just a coincidence that it's found next to the reddened sediment and next to the heat-shattered hand axes. And then we thought, we've done so much geological work in the area. This includes identification of 121,000 individual bits of rock, and 30,000 of those come from Barnum, and not a single piece of pyrite was found in those geological samples. In other words, humans brought the pyrite to the site. So now we have evidence that this reddening was caused by heating. We have evidence that humans were at the site through the heat-shattered hand axes, and then, you know, the pyrite in close association. I had a real hunch that we're onto something big.
We've now seen the excavation site, and we've also seen some of the key pieces of evidence that make this such a strong case for humans using fire. But we still need to make sure that it's humans who are making the fire. And to do that, we need to go to the University of Liverpool, where Sally Hoare has been doing some amazing research to unlock the final part of this puzzle.
I came in at the point where there was all these different strands of evidence started to come together, and I was specifically obviously involved to analyse that patch of reddened clay. Within soils we have, say, tiny fragments of clay, and when these are exposed to high temperatures they undergo tiny but permanent changes to their magnetic properties. We take samples from inside the reddened clay and also outside of the reddened clay, as we're looking to compare what the different magnetic properties are of soils that have potentially been heated and those that weren't. So we use a variety of instruments to take the measurements, like this one on the table, which is a magnetic susceptibility meter, and it's basically generating a low magnetic field which is travelling down this wire into the sensor. We have iron oxides present in these soils, and these are minerals that contain iron particles. So when the magnetic field hits those iron particles, the iron atoms within those particles momentarily align with the magnetic field. And if we've got a lot of iron oxides in those soils, for example those that are created through heating, the response is going to be very strong. The instrument then converts that via a feedback loop into a number value, and we simply read that number on the screen.
This all seems rather straightforward. You take a magnetic measurement of soil, and depending on whether it's been heated or not, you get a different value back. However, this is just measuring one magnetic parameter. By measuring multiple magnetic parameters, Sally could do something really interesting.
So if you think about it, if a natural fire goes through, it tends to result from a single extensive heating event. Whereas when humans are using fires, they're using it over and over again in the same spot for different purposes like light, heat and cooking. So magnetic measurements can tell us whether soils have been repeatedly heated. We also take a larger bag of unheated sample of the natural soil that the reddened clay formed out of. And this is so we can create our own experimental reference data set. So we heat small samples for different lengths of time. And this tells us what the magnetic properties are of a single extensive heating event, so that's more similar to a natural fire. We then reheat those samples over and over again. And this tells us what the magnetic properties would be like of soils that have been heated 4, 12 and 24 times. This gives us a comparison point for the archaeological samples, so we can compare the magnetic properties from those reddened soils with our own experimental data set. And what we can say conclusively is that they were exposed to multiple heating events. We can't say exactly how many times the reddened soils were heated, but it could have been as many as 24 times.
Sally also showed us that the type of hydrocarbons associated with human-made fire, called high-ring hydrocarbons, were found in much higher quantities in the soil samples from the excavation site.
If we look at this sample here, this is our reddened soil. And we can see straight away that it's the only sample that contains more high-ring hydrocarbons than any other sample we've analysed. All our other samples contain a dominance of this low-ring hydrocarbons, and that tells us that we've got repeated human fire use that's localised at that site. One method on its own really isn't enough to definitively say we have human fire, which is why we use so many different methods. So with each result, it becomes more and more exciting, it becomes more and more tantalising that we can say definitively that there was a fire here in this exact spot. It was heated multiple times and could only have produced by human activity and not natural fires.
This was it. This was the moment the team could say, beyond reasonable doubt, that they had found evidence of humans making fire. The reddened soil, the heat-shattered hand axes, the pyrite, and the evidence of not just heating, but multiple heating events all came together to form this conclusion. But why does this matter? And why is fire so important anyway?
We're almost certainly talking about early Neanderthals, so the thought of them creating fire 400,000 years ago is absolutely astonishing. And what does this mean? We've always assumed that the technological advances come from our own species in Africa, but here we have potential evidence that actually early Neanderthals were the creators of fire, and it spread from here to other parts of the world. And of course, in Northern Europe, you have far more evolutionary pressures to actually not just use fire, but actually make it. Northern European winters can be quite cold, and heat in winter must have been essential. You've also got protection. We know that there are large carnivores, particularly large lion, roaming Britain and Europe at that time. And then we have cooking. For the first time, when you can consistently make fire, you can have cooked foods on a regular basis. And this transformed their lives, and it also transformed their bodies. Through more tender food, the digestion system changes, the gut becomes smaller, and this frees up energy, and it frees up energy for development of the brain. To us, fire is also an essential social hub. We can all visualise sitting around a campfire today, and this must have been the same for these early Neanderthals 400,000 years ago. Suddenly you're telling stories, you're communicating in new ways, you're strengthening those social bonds, developing language, and possibly even early belief systems. I think we always had the feeling that control of fire happened quite early, but now we have the actual evidence to prove it.
It's very special to be here, and you know you're the first person to uncover what happened around this fire 400,000 years ago. You know that. It doesn't mean it was invented 400,000 years ago. Maybe we'll find it's even earlier. It's at least that age.
It's a game changer for early human fire use. It's a game changer for the appearance of fire as a technology in human evolution. So to be involved in this project, it's probably a highlight of my career.
This couldn't be a lightning strike, it couldn't be a wildfire. It was all in this one isolated location next to the human evidence, next to the pyrite. A magical moment when my hunch was confirmed.
Archaeological discovery, it's not always something that you identify as soon as you see it and you know what it is and you know you have done a great discovery right now. Sometimes it really comes from all the investigation, putting many different clues together, and that's really what we needed to show that this fire was human-made.